Unit 3, Day 1, simplifying rational expressions. Well, let's talk through what each of those words mean, and then we'll do some examples together. Simplifying means we want our answer right as one fraction. So we're going to get expressions with 2 and 3 fractions, probably not more than 3. And we want to either add, subtract, multiply, or divide and get those into one fraction. So that's the goal. We already mentioned that ratio means we're dealing with fractions. Expressions as opposed to equations, so not equations. So we're not solving anything today. So we will not get x equals 12 as an answer. We might get x over 12 or 12 over x. We'll get a simplified problem, but we won't be able to do anything with it because there's not an equation, no equal sign. So the goal is to turn it into one fraction, or we're dealing with fractions, we're not solving them, we're simplifying them. And we're kind of just going to go in the order of how you first learned how to do fractions. First thing you did was add and subtract. We can combine that into one Roman numeral because that's pretty much the same thing. And kind of like we did with long division, we went back to our 4th grade selves to remember the process. Let's do that here, although I think you don't have to go all the way back to 4th grade. If we want to do 2/7 plus 3/4, when did you add fractions? Middle school somewhere?
You have to change the denominator.
Yeah, I need a common denominator. So no variables in this one, but this is just reminding us, big picture how we do this. We need a common denominator. And I can do the first one by 4. But whatever I multiply to the bottom, I got to multiply to the top. That way it doesn't change the value of the fraction. And then the second fraction, I could multiply the bottom by 7. So now the denominators match. They have that in common denominator. But I can't just multiply the bottom. That would change the fraction. So we also multiply the top. That's a really slow process for adding fractions, but it's the same process when we get the letters. So we wanted to slow down and take it easy on the first one. So the denominator is in common now. That's the whole point of a common denominator. That's the same. And the top is 8 plus 21. So we keep our denominator, we add the numerators. 29 over 28. Okay, that's our middle school reminder of how to add fractions. Things are going to get a little more difficult though, because we're going to do it with variables. So let's do 2 over x plus 2. And then leave a little space because we're going to have to do a common denominator, so give ourselves room to work. Plus 4x over x minus 1. So how do we make these denominators match?
Multiply -2.
Multiply. You're right, I multiply. I can't do any adding. Like I can't add 3 to this second denominator to turn it into x plus 2. That's not legal. I have to only multiply things. And so the first term needs an x minus 1. Second term needs an x plus 2. That's the only way to get them to be matching. Because the only thing you're allowed to do to make a match is multiply stuff. Alright, so our denominator is good now, meaning it's the same for both of them. And then we've got a little bit of work in the top here. 2x minus 2 plus 4x squared plus 8x. So combine like terms, 4x squared plus 10x minus 2 all over x plus 2, x minus 1. The goal was to turn it into one fraction, and we did that. Right, x over x squared minus 25 plus 1 over x minus 5. And again, I'm leaving space because I know I'm going to have to do some common denominator stuff. Leave a little bit more space. We're going to add 3 terms this time. Plus 2x over x plus 5. I want my denominators to match. Thoughts on what we should do first? Yes, sir? Did you say squared? I think you misspent x plus 5 and x minus 5. I think you said x squared plus 5 and x squared minus 5. I know that's not what you meant. X plus 5 and x minus 5. Which is good because now they're closer to being in common. So we need them to all have the same stuff. So what does the first denominator need?
X plus 5.
Not what does this one need?
Nothing.
Nothing. He's got everything. The next one needs an x plus 5. And then the next one needs an x minus 5. Okay, now the denominators are matching, so we're good there. Now it's just a matter of cleaning up the numerators. So I'm going to write it all over that one common denominator. So x from the first term plus x plus 5 from the second term plus 2x squared minus 10x from the third term. And then we'll just collect like terms, so 2x squared minus 8x plus 5. Over x plus 5, x minus 5. Let's do one more of those. 3 over x squared minus 25. Leave some space. Minus 3 over x squared plus 6x plus 5. Surely no one's going to do this, but once in a while, a student says, oh, look, 3 minus 3 is 0. Well, I mean, yes, 3 minus 3 is 0, but that's not what's happening here. You have to have a common denominator before you even look at the numerators. So let's look at the denominators first, and what should we do first with these two denominators? Factor them. And when we factor them, we may discover that they have something in common already. And it doesn't matter that they both have two things. They all want the same thing. It's like my children in the back of the minivan on a road trip, right? Like, if everybody doesn't have the same thing, then it's whining and complaining. And so even though they both kids got two things, first denominator looks over at second denominator and says, it's not fair. What does first denominator want to make it fair in his mind? He wants an x plus 1. And probably poor parenting to just give in and let him have an x plus 1, but that's what we'll do for adding denominators. Of course, now the other denominator is like, wait, Dad, that's not fair. Why can't I have a x minus 5? Sure, son, just whine about it and I'll give it to you. Not really. I hope we don't parent like that. All right, but now everybody in the back seat is content and happy. They've all got the same denominators. The order doesn't matter because they're being multiplied. Now let's worry about the numerators. So 3x plus 3. Oh, careful with that minus sign. That minus sign basically needs to attach to the 3. So minus 3x plus 15. You good, Luke?
Yeah, I see.
So that negative goes with the 3, and then when we distribute it becomes a plus 15. 3x's cancel, and that leaves us with 18 over all of the snacks in the back seat. X plus 5, x minus 5, x plus 1. So get all the kids equaled out, and then add the numerators. That's for adding fractions. For multiplying fractions, Roman numeral 2, multiply. Do I need a common denominator to multiply fractions? What was that? Kind of a mumbled. Do I need a common denominator to multiply fractions?
I heard somebody say no. So I'm gonna agree.
You can agree with him just because you heard it, or because you agree with?
No, I just heard it. But I just agree.
2 ninths times 3 eighths. So again, let's back up to middle school, remind ourselves how to multiply fractions, and then we'll fast forward back to pre-cal and do it with variables. But the process is the same. So, well, I guess there's two ways to go here. One way to do it is to just multiply across. 2 times 3 is 6. 9 times 8 is 72. And then I need to reduce. So 6 goes into 72 12 times. So 1/12. Do you remember what's the other way to do that? I wouldn't say cross multiply. I mean, you're looking at the right thing.
The butterfly.
Cross reduce. I don't know.
Cross reduce. That's a better description of what you're going to do. Anything in the top is eligible to reduce with anything in the bottom. So where they are left and right doesn't really matter, as long as something in the top reduces with something in the bottom. So like the 2 and the 8, that could reduce to 1 and 4. And the 3 and the 9, that could reduce to 1 and 3. And now, of course, you gotta be careful when you do this method to be neat, so you can remember who's crossed out and who's there. In the top is 1, and in the bottom is 3 times 4 is 12. So yeah, we got the same thing. So we had to reduce. It's just, did you want to reduce first or did you want to multiply first? I think it's easier to reduce first because it gets you dealing with smaller numbers. If you wait to the end to reduce, you might have bigger numbers than you want to mess with. All right, but the big thing is no common denominator needed. And that's probably the most frequent mistake, is students getting a common denominator to multiply. Right. X plus 3 over x plus 1 times x plus 2 times x plus 1 squared over x plus 3. So if we were looking to cancel first, do I have any?
Plus 3s can cancel.
The x plus 3's can definitely cancel. Anything else can cancel? The x plus 1, although we got to be careful, there's 2 of them in the top, there's 1 of them in the bottom,
So one's left over.
so 1 can cancel, 1's left over in the top. So we're left with an x plus 1 in the top and an x plus 2 in the top. Negative 4x times x plus 7 times 5 times x minus 2 over x times x plus 7. Okay, anything you see we can cancel out there?
X plus 7.
Definitely the x plus 7s. Good, the negative 4x and the x. Some people, when they get attached, they think that 4x is, it's 4 times x, so I can cancel with the x in the bottom. But be careful, the negative 4 is still there. Sometimes I'll see people like circle stuff to sort of remind themselves that it's still there. I didn't cancel that. So that's negative 20 times x minus 2. And then what's left in the denominator? Nothing. So here's one of my favorite answers. Boxes that up. So, well, I know the denominator went away, but that's not usually how we would write that. If you don't have a denominator, then you don't need a denominator. Don't write it like that. Just simplify it. Let's do one more multiplication problem. Ten over x squared plus 4x plus 4 times x squared minus 4 over 2x squared minus 2x minus 4. So, thoughts on what we should do first with that? So let's factor, not just this, let's factor everybody. Let's factor as much as we can and see what happens. So x plus 2 and x plus 2, or x plus 2 squared. But when it comes to canceling, sometimes it's easier to deal with x plus 2, x plus 2. The top would be x plus 2, x minus 2. And then, what do I do with this guy? Well, careful when you say divide by 2. Let's factor out a 2. And then we'll factor what's left. So it'd be x minus 2 and x plus 1. All right, now that everybody's factored, I can look for things to cancel. So what can I cancel?
X plus 2.
Yes, maybe. Which ones? There's 3 of them. Do they all get to go away? Right, one from the top with one from the bottom. So definitely the x plus 2 in the top, and then it doesn't matter, pick one, not both though, because they got to pair up and cancel. So the x plus 2's cancel, the x minus 2's cancel. Anything else? The 10 and 2 will reduce to 5 and 1. Again, be neat so that you can tell what's left after you've gone through and marked a bunch of things out. 5 is the only thing left in the top. X plus 2, x plus 1, the only thing left in the bottom.
What about the 1? That doesn't matter.
It doesn't matter, you're right. If you want to put a 1 down there, you could. And I guess you could even stick a 1 out front. It wouldn't change anything. A multiple choice, it wouldn't be wrong as a free response answer. A multiple choice answer wouldn't be there. But I don't think that would throw you off. All right, lastly, dividing fractions. Dividing fractions, that's a little bit trickier. Do you remember how you divide fractions? So it's all the same thing, but teachers say it differently. I heard keep, change, flip. Or keep it, change it, flip it. That's usually what I say. Except that's not, it's right, but there's a lot of it's in there. Keep it, change it, flip it. Keep what? Keep the first fraction, or the top fraction. Change it. Change what? From what to what? No, but you're on the right track. Yeah, division and multiplication. We do this for divide problems, so it looks like a divide problem, but we're going to change it to multiply. I'm going to make it a multiply problem. And then we say flip it. Flip what? Flip the second fraction, or the bottom fraction. Or I guess it's the second fraction if you write it straight across. I don't know. When dividing fractions, don't be shy. Flip the second fraction and multiply. Silly. Keep it, change it, flip it. Whatever works for you. Keep the top. Change the multiplication. Flip the second one. So let's do a middle school one first. So 2/15 divided by 6/5. And I would not start reducing until you keep it, change it, flip it. Because it's like, well, what exactly reduces with what? You can figure it out, but it's much safer to keep it, change it, flip it, and then figure out who's eligible to cancel. So keep it, keep the first one, change it to multiplication, and then flip it, flip the second one. So that would be 5/6. Now let's look for things to cancel or reduce. Let's see, 15 and 5 puts a 3 in the bottom. 2 and 6 puts a 3 in the bottom. And once again, we have one of my favorite answers. Blank over 9 is our answer. Not really. What's the answer? What goes in the top there? Yes. 1/9. Keep it, change it, flip it. All right, well, let's do that with some letters now. X over x minus 2 over 3x over x squared minus 4. When dividing fractions, don't be shy. Flip the second fraction and multiply. Or just keep it, change it, flip it. Keep it, change it. I'm feeling adventurous today. I think I want to do 2 steps at once. So I flip it. What else do I need to do with that x squared minus 4? I need to factor it. So you could factor it first, or you could flip it first, or you could just go crazy like I'm about to do and do both at the same time. Yeah, it's Friday. I'm feeling kind of wild today. Now I can look for things to cancel. X minus 2's a clear choice, and then the x. Yes, the x. Careful when you cancel it, just to make sure you know the 3 is still there. And so we're left with x plus 2 over 3. Okay, we're saving the worst for last here. X over 5 minus 3 all over 4 plus 2 over x. What? X over 5 minus 3 over 4 plus 2 over x. Well, I can't keep it, change it, flip it yet until it's one fraction over another fraction. So I'm going to make it one fraction over another fraction. There's different ways to work this problem, but to me this is the easiest way. I'm going to fix the top, and by fix it I mean make it one fraction. So that's a subtraction problem. Then I'll fix the bottom. And again, by fix it, I mean make it one fraction. And then I'll have one fraction over another fraction, and I will be eligible to keep it, change it, flip it. So this problem has add, subtract, multiply, and divide in it, all of them. Okay, how am I going to add the numerators here? What do I need? Common denominator. So I'll put a 5 on that second fraction, give it a 5 denominator, and then a 5 numerator. And so my sort of overall numerator now is x minus 15 over 5. For my denominator, my first denominator, or my first fraction, needs an x in the bottom, which means it needs an x in the top. So 4x plus 2 over x. We fix the top, we fix the bottom. Now we can do keep it, change it, flip it. X minus 15 over 5. Keep it, change it to multiplication, flip x over 4x plus 2. And what's eligible to cancel in that one? Nothing. It's kind of frustrating. You make it that far, you're hoping that, like usual, a bunch of stuff cancels and it simplifies. And so students think they've mess something up, but sometimes nothing cancels. But the goal at the beginning wasn't to get stuff to cancel. I mean, sometimes that happens. The goal was to turn it into one fraction. And so this problem started with a mess, and we did a lot of things and got it down to one fraction. Last one. 1/5 minus 1x, 1 over x, over x minus 5. 1/5 minus 1 over x, over x minus 5. So how do I fix the top? Okay, Top or bottom?
Both.
Good.
And the others have like balance, but top and
So now I've got x minus 5 over x all over x minus 5. Again, I would not cancel until you do the keep it, change it, flip it.
Is it 5x or x?
Uh-oh, yep, it's 5x, thank you. I was so eager to say, don't start canceling until you keep it, change it, flip it. Because sometimes you think they'll cancel and they won't. Sometimes you think they won't, but they will. And even if they will, sometimes it's hard to make sense of, if those do cancel, what do I do with the 5x? Like, is it in the top or is it in the bottom? Like, keep it, change it, flip it. Keep it, change it. Oh, how do I flip x minus 5 if it's not a fraction? Yeah, just make it a fraction, 1 over x minus 5. And then now this is easy, the x minus 5's cancel, and we're left with 1 over 5x. The danger in that problem is canceling the x minus 5s, which would be okay because they did cancel, but then students get confused on where's the 5x, because it's in the bottom of the top, so where does that make it go? Write out the keep it, change it, flip it, and then worry about canceling stuff. Alright, today's assignment's worksheet 1. I'll pass that out.